Hello viewers, welcome back to another section of our tutorial video. Still on apply electricity. In this video, we have this complex circuit here and you have to find the effective resistance of this circuit. From our source here, we have a straight branch containing 3 ohm resistor, then we have another branch containing 2 ohm, then we have these branches 4 ohm and 6 ohm respectively. So how do we find the effective resistance? From the previous video, we learned that whenever you are working on a complex circuit, we work away from the source, then gradually we move towards the source. Number 2, we consider 2 resistors at a time. So let's apply these principles so that we solve this problem nicely. Kindly watch this video to the end so that you understand every part of the video. So working away from the source, you are going to consider the 4 ohm here, then the 6 ohm resistor here before we move into the circuit. So considering these 2 resistors, are they in series or they are in parallel? You will see a node here, then you see another node here. For that reason, this is not a node. Take note, this is not a node. This is a node because there are more than 2 branches meeting. I have one branch, so here is a node. Current can make a decision here, but at this point current will just pass here, so this is not a node, so take note. So the presence of this node and this node makes this parallel, and also you can confirm alone because when you traverse through them you can see that they are the only resistors or they are the only elements you can find, hence they are in parallel. So since they are in parallel, you just write your 4 ohm resistor is in parallel with your 6 ohm resistor. Then let's solve that part. Then after you redraw the circuit. So solving this part, you get 4 times 6 over 4 plus 6, and that will give us 24 over 10. So we get our resistance to be 2.4 ohm. Then we redraw the circuit so that you have our voltage V out here, then you have our 3 ohm here, then you have our top here. But when I reach this side, they have been collapsed to form 2.4, so that place will be 2.4 standing, so 2.4 ohm. Then I have my 3 ohm here, then this our V. So we have the 2 ohm here, so that will be here 2 ohm. So you keep on redrawing after every combination, so this and this combine to form this branch. So once you have these parts, now we ask ourselves, these 2 branches which are out here, are they in series or they are in parallel? Is there a node? You realize that this is the branch. Take note, this is the branch, and at the branch here I have 2 ohm, 2.4 ohm. If the current is passing, you realize that the current will pass through these 2 resistors nicely, and the same current will pass through them. Since there will not be any current division, then this and this are in series, so we add this and this, so you have 2 ohm plus 2.4 ohms, and that is giving us 4.4 ohms. So our total resistance, and drawing the circuit, you have our 3 ohm here, then we have our 4.4 ohm, 4.4 ohm, then the 3 ohm here, and this is our V. Gradually we are approaching the source here, so let's see. Now we ask ourselves, these 2 resistors, since there was a node here, this is a node, and the current now be coming from the source, will have to split before it gets into this. Because of that, this and this are in parallel. Then when I traverse through them, they are the only 2 elements in this circuit or in this loop. For that reason, our 3 ohm is parallel to our 4.4 ohms. Hence, you have 3 times 4.4 over 3 plus 4.4. And what are we going to get after simplification? So from here, when you simplify, you are going to get 1.78 ohms. Thank you for watching this video. Don't forget to like, subscribe, and share. Turn on the notification button so that I get updated of the rest of our tutorial videos.